Alrighty class, today we'll be looking at an order for lesson, section 7.3, multi-step equations with decimals and fractions. It can be found on this page. I know those last words right there just make you so happy. Well, let's just jump right in and start solving these problems. Okay, so first off, let's take on problem example number 1. We have 2/3 n minus 6 equals 8. So, what should we do? Well, just like all the other problems that we've solved so far, we need to get rid of this number 6 first. So we're going to get rid of 6. What we do is we simply write down our little fraction right there, and we simply write it right there with our n. And we've, oh sorry, I forgot, getting too far ahead. We need to add 6. Add 6 to get rid of it. So then you copy down the 2/3 n, and it's going to equal, well, it equals 14. Next, we need to get rid of this. Now, you should remember how to remove a fraction. You could divide, but remember, dividing by fractions is weird and kind of complicated. There's something easier you can do. You can, see if you remember, it's called multiply by the reciprocal. That's an awful cough. But yeah, we can multiply by the reciprocal. So I'm going to rewrite this again. 2/3 n equals 14. The reciprocal of 2/3 is 3/2. So you multiply both sides by 3/2. So these, remember, reciprocals when multiplied together cancel each other out completely to 1. So it's gone. So we're left with just our n equals. Well, if you want, you remember you can put the 14 over a 1, and if you look, you can cross reduce. Remember, you're allowed to cross reduce so long as you're multiplying normally. And we're multiplying normally here, so we can just cross reduce these problems. So you would say, well, that changes to a 7, that changes to a 1, so you would have 7 times 3, which is 21, and 1 times 1 is 1. So you'd have 21 over 1, which is just 21. And so that's your answer, okay? Yeehaw. Moving on to the next one. Once again, a problem where we have a number up against a parenthesis. It'd be a good idea to go ahead and distribute this. So we go ahead and distribute this to get rid of it is one method we could use. So 3/5 times m would give you, well, 3/5 m minus, well, and now 3/5 times 20. If you want, you can use, your side work over here. Always use this when necessary. Come over to the side and put down your 3/5 times 20. Put it over 1. You can cross reduce 4, 1, so you end up with what? 12 is equal to 3. Okay? Okay. So now we need to get rid of the 12. So we're going to, again, we're going to add the 12, add 12. We're adding because it says minus. We do the opposite. Copy down what's left. We have the 3/5 m is equal to, that would be 15, okay? Now we need to get rid of this, so we need to multiply by the reciprocal, so 5/3 times 5/3. If you do this, this cancels out, giving you just your m is equal to, and this would reduce all the way to 25, okay? So we would get 25. If you want to do this, work over the side to get the answer, but 15 times 5 over 3 is 25. Do the work to the side if you don't believe me. Go on, do it. Go ahead, do it. Okay, next we have this problem right here where we have 4/5 x plus 3 equals 1/4. So here we have 4/5 x plus 3 equals 1/4. This is where it could get tricky. Now I'm going to show you a trick. Now before, if you look up here, notice how many fractions were in each problem. 1 and 1. when you start getting multiple fractions involved, especially when they have different denominators, it can cause a lot of problems because you're going to have to find a common denominator when you add or subtract, and you will have to subtract here. It just causes problems. So one of the easiest things to do is to get rid of your fractions. And it's typically not worth doing this if you just have one fraction, because it's almost the same amount of work. But if you have two fractions, this extra step actually saves us time. So what we're going to do here is we're going to find the LCM of the denominators. And maybe you want to write that to the side over here where you have the space, right? Find the LCM of the denominators. Once you find that, we multiply the entire thing by that, both sides by that number. So what is the LCM for 5 and 4? Well, that would be 20. So we're going to say times 20. So we're going to say times 20. And we're going to put a parenthesis here, and I'll tell you why. Because this side has more than one term. Remember, terms are these things. So the 4 over 5x is one term, and the 3 is another term. So we got to use parentheses when we're doing with more than one term, so that we make sure that we distribute the 20 properly. Now this at first looks weird, but it's just because it's so different. It's just that it's different. It's not actually complicated what we're going to do, okay? It doesn't make this any more difficult, in all honesty. It's just weird maybe at first, but then once you get used to it, it's like, oh, this is so easy. So now we have our times 20 for this side and our times 20 for this side. So now we need to simplify this. This is going to get rid of our fractions, because 20 times 5 over 4, or 4 over 5, if you want, again, you could come to the side to do some scratch work. But 20 times 4 over 5 is going to give us 16x. So now we see how we don't have a fraction anymore. Plus, now 20 times 3 is going to give us 60. Equals, now if we multiply these together, we would end up with 5. So now you have 16x plus 60 equals 5. A whole lot easier to solve this than it was the other problems we were trying to do before. So now it becomes a normal two-step problem, and you just subtract 60 from both sides. You end up with 16x is equal to negative 55. You would divide by 16, and you would get x is equal to, well, what does x equal? I would just go, maybe go over here and do your scratch work where you would do 16 goes into 55. We just need to know that the answer is going to be negative, okay? So 16 goes into that. Let's see, is it, what, 3? 3 times 3? Let's see. 3 times that is that, 3 times that is that. Yeah, it looks like it's going to be 3 times. So if you say 3 times that is your 18 with that, and 10 times that, you get this. You end up subtracting, and you end up getting, what is that, 7? Yeah, so you have 7. 7's our remainder, so we put 7 over 16. So you have negative 3 and 7 over 16. So negative 3 and 7 over 16. Now, you might think that takes a lot of time to get from here all the way to there, and it does, but you would have gotten the same answer even if you haven't gotten rid of these. Now, maybe you will say, well, I don't think it would have been that difficult to, just to keep the fractions there. Well, maybe not. If you want to, you can work it without using the LCM method, but you do need to know that it exists, because sometimes it's easier to use that than it is the other way, okay? So keep that in mind. And yes, it does take a little while to get to the answer. Hence the name of the title, multi-step equations. Get used to it. By the time you get to Algebra 1 and geometry, this will be considered a short problem. So don't bother coming in and complaining about this being long, or else I'll give you a really long problem if you want it. So let's do one last example, because if you've noticed, the section did say we would have decimals, and so far we've only used fraction examples. So here's an example with decimals. Once again, we would need to just get rid of these two numbers because it's on the side with the variable. So we need to get rid of this 3 first. So we're going to add 3 to both sides. We add 3 to both sides. And so if we do that, you end up with 1.06p is equal to 3.71. Now please remember, when you're adding a whole number to a decimal, you got to line it up. This 3 lines up with the 0 because the 0's in the ones place, just like the 3. And so you add that 3 to the 0, not to the 1 back here. So you would get 3.71. Make sure you line your decimals up. If you have more complicated numbers than this, it's helpful to, again, go to the side and use some scratch space area to do that, and then come back here. We always want to keep this kind of neat and flowing downwards, and this over here is where we're going to do any scratch work that might take us a little bit more time. That way this looks all nice and neat, and I can clearly see your steps and see what you've done. And that way I can see, oh, there's a mistake here, and then I can look over at your scratch work and see if you made a mistake over here or if you copied it wrong. It makes everything easier for you and for me. So get used to doing it like this. It's the best way going forward. And you are in 7th grade or 8th grade, so you have at least 4 to 5 more years of math. Okay? So might as well learn this now because it's to your benefit, okay? So trust me. All right, moving back to the math, enough of the lecture time. All right, we need to get rid of this, so we have to divide by this. Divide by this. Okay? So we end up with P equals, now in order to do this, we will have to go to the side to do some scratch work. It's just a little too much complicated for even me. I don't want to try this in my head. So we write it down like so. And remember the rules of decimals and dividing, that we don't want decimals in our divider, so we move it on out. We end up with 106. Since I moved the decimal twice on the outside, we have to move it twice on the inside. Voila. 106 into 370. Well, I'm going to guess the first number is 3. Multiply back, and you would end up with 318. You would need to subtract, so we're going to borrow. That becomes an 11, which is a 3. That's a 6 now, minus 1, which is 5. Okay, so now we just bring down a 0. Now this is where the decimal is, okay? So it's understood as decimals there. Bring down a 0. And I'm betting that goes in 5 times. You multiply that, you do get 30, and you get your 5, and you subtract, and hey, look at that, you get 0. So our answer comes out to be P is equal to 3.5. At first, this looks like it's going to be complicated. You're like, oh no, it's so difficult. Look how easy that was to get the answer. Not difficult at all. So, yeah, don't think it's too complicated. So this section, the important thing is going to be remembering your rules with fractions, remembering your rules with decimals, and remembering that when you have 2 fractions in a problem, you can multiply by the LCM to get rid of all your fractions. This is going to take time. The key to doing any work like this is writing down your work clearly, neatly, and writing down every step so that you don't lose your place, okay? So I'm going to require that you do that. So get used to that and come into class not complaining. All right, I'll see you in class. Bye.